I am Sridhar Babu, your mathematics mentor. Today I am going to teach some problem solving skills in complex numbers chapter. We are going to mix problem solving skills with basic conceptual understanding. So every time when I solve a question, I will explain the concept and then I will give you the problem solving idea. In some questions, I may not be able to complete the simplification process as usual because of the time. So you can work out them at home and see if you are doing it correctly or not. And also keep a notebook in front of you, keep making notes. If you find some interesting ideas, please note them. And also for solving problems, today the methods that we are discussing can become your algorithms for problem solving. So if there is a particular type of problem, you can develop a or design a methodology, we can call it as algorithm, and you can note it down in the notebooks so that in the exam when you attempt any question, when you read any question, your planning becomes very fast. Okay. Also, if you have not downloaded the app, please download the app so that you can communicate with us. Now, before I proceed, there have been many comments that we have been seeing every day. So there is also a student named Harsha who has sent a snapshot of a supermarket, and he has been saying yo sir, what's up sir. So these kind of things are fine, but try to focus mainly on the academics. Okay, can we start? So this is the first question. To understand this question, we need to understand the geometry of complex numbers. Now, what is the geometry of complex numbers? Argand plane, there is a plane named as Argand plane. Argand plane is designed to represent all complex numbers that are existing. So now, on the Argand plane, whatever happens to z or mod z or argument of z or how to interpret all of them is the first and foremost essential concept that you need to understand. Okay. So here suppose let us say if I take one axis and another axis. So generally this type of rectangular coordinate system is used to represent coordinate system, 2D geometry coordinate system. But here in complex numbers also we are borrowing the same concept of coordinate system to represent all complex numbers, but with a slight change. What is the change? This axis is called as the real axis, this axis is called as the imaginary axis. On real axis all purely real numbers are put, on imaginary axis all purely imaginary numbers are put. Suppose let us say we want to plot this number 2 plus 3i. How do we plot it? We have to take 2 units on real axis and 3 units on imaginary axis. So that means this point can be denoted with 2 plus 3i. So here we can understand that z, which is a complex number which is in the form of a plus ib, is also a point on Argand plane. So it's a number, it is also a point. Now there is also another third identity for this, which is because these 2 and 3 are representing the location, we can also take it as a position vector. For example, let us say this is my z equal to 2 plus 3i. See, if you notice, I write 2 and z in the same way, but z will have a cut, 2 will not have a cut. Please get used to it. Okay. So now because this also represents this point 2 comma 3, we can also treat the complex number as a position vector. Is this clear? So z is a number, it is a point, it is a vector. So there are 3 types of identification for z. Now what is mod z? Mod z represents distance. On coordinate plane, on Argand plane, mod z represents distance. Algebraically, mod z is a non-negative number. You know how do we get mod z? Mod z is root of real part square plus imaginary part square. So all the outputs that come out of square root are always non-negative. So we can say that mod z is always a non-negative number. But here on Argand plane, mod z represents distance of z from origin. Now, if I take mod of z1 minus z2, then this means it is distance of z1 from z2. Okay. Now, also mod z can be treated as the magnitude of the vector. Magnitude means it is the direction plus magnitude. Magnitude represents the distance only. Okay. Suppose let us say we have a vector something like this. Now, to represent this length, we use the terminology magnitude. Okay. So, magnitude and distance are one and the same, but there is a different terminology. Now, also there is another concept called as argument. Argument is defined as the angle made by the z, z is position vector, remember, angle made by z with positive real axis. That means, suppose let us say we have a vector like this, that means this angle will become the argument of z. Now, if z is somewhere here, then argument is to be measured in this direction. Okay. That way there is a also concept of principal argument, which is like what is the range of this argument? It goes from minus pi to plus pi. So, that means if you are in third and fourth quadrants, measure the angle in this direction. If you are in first and second quadrants, measure the angle in this direction. Okay. So, this is the basic concept of geometry of complex numbers. How do we understand z? It is a number, it is a point, it is a vector. How do we understand mod z? It is a non-negative number, it is distance, it is the magnitude of vector. How do we understand argument of z? It is the angle made by the vector with positive real axis. These are the concepts that you need to proceed with today's lecture. Okay. So, can we go ahead? Now, I will solve this question. So, the first as I used to say earlier also, every question has a different data. So, beta, everything is about data. So, you should be able to interpret that data in a correct way and also appropriately. So, here this is one information, this is one information. Now, let us try to understand this information. This means there is a point, let us say the point is 3, 4 here, 3 plus 4i, this is the point. Now, there is one z1 which is varying, z1 is varying because it is not given as a fixed complex number, we have to take it as a variable complex number. Now, z1 is varying, 3 plus 4i is a fixed number, that means that point is fixed, z1 point is varying, but the distance between these 2 points is always constant. So, between z1 and 3 plus 4i, distance is always constant, which is 5 units. This means the locus of z1 is a circle, z1 must lie on circle. So, first statement means, this information means z1 lies on a circle of radius 5 units. So, we can imagine a circle here of radius 5 units. Okay. Similarly, if you also observe this, so there is a point minus 6, minus 8, and from this z2 is varying such that from this point distance is always 2. That means z2 also lies on a circle with distance 2 units. So, here there are two information. So, one information means it is a circle, second information means it is also a circle, but these two are two different circles located differently. This is the given information. Now, we have to find the range of 3z1 minus 2z2. Now, before I proceed with this, let me give you this simple idea. Find the range of, let us say, mod of z1 minus z2 is given. Then what does this mean? z1 is varying on one circle, z2 is varying on another circle. You want the distance from z1 and z2 to be minimum and maximum. Now, how do we do this? We can do this using simple pure geometry. Okay. So, let me just solve this one more time. We got one circle here, center is 3, 4, and the radius is 5 units. We got another circle here. The center is minus 6 comma minus 8. This center is minus 6 comma minus 8 and the radius is equal to 2 units. So, here on this circle Z2 is present, on this circle Z1 is present and we want to find the minimum and maximum of distance between Z1 and Z2. Now, how do we do this? So, if you look closely, because these two are circles and there is also symmetry in circles, the line joining centers will create symmetry whenever there is a combination of two circles involved. So, here what we have to do is we have to join the centers and we have to observe. Okay. So, suppose let us say if I join the centers and observe, this distance which I am marking here, this distance will be the minimum of mod of Z1 minus Z2 and from here to here this will be the maximum of mod of Z1 minus Z2. Suppose let us if I name these as A, B, C, D, E, F, then minimum is E, B and maximum is F, D. Minimum is E, B, maximum is F, D. So, if you observe this geometrically, then you can crack this question very fast. Okay. So, how do we do this? EB can be written as AC plus R1 plus, okay, so here a slight change. AC minus R1 minus R2, because from AC if you remove this part which is the R1, I am just taking it as R1 and if you remove this part also you will get EB. So, EB can be calculated this way and FD also can be calculated in similar way. So, that can be written as AC plus R1 plus R2. So, with AC we have to add this R1, we have to add this R2. So, that way you can calculate the maximum and minimum distances. Now, to find AC here, you need to find the distance between centers, that you can do using distance formula. Okay. So, here if you apply the distance formula, because this point is 3 comma 4, this is minus 6 comma minus 8, you know that this distance is going to come out to be 15. So, here AC will be 15. Now, from 15 you have to subtract both radii, that will be 8, this is the minimum value, and with 15 you have to add these both radii, that will give you 22. So, minimum is 8, maximum is 22, this way you can calculate it. Okay. So, here till we understand the situation, till we understand the diagram correctly, the complex number chapter is, but after that once if we are clear about the diagram, then the entire analysis and solving goes into simple school geometry. Okay. So, in most of the questions that are going to come up, I will try to explain till the geometry part, till you understand the idea. Later on workout you can do it anyway on your own. Okay. Now, here I have explained the problem where we need to find the range of mod of Z1 minus Z2, but not this. Now, how do we proceed with this? For that there is a very simple idea. If we take the first equation, which is Z1 minus 3 minus 4i is equal to 5. If we multiply this with 3, then we get something like 3Z1 minus 9 minus 12i equal to 5. So, here I take this 3Z1 as A. So, that means this becomes A minus 9 minus 12i equal to 15. Similarly, for the second one, Z2 plus 6 plus 8i whole mod is equal to 2. Because we want 2Z2 here, I multiply this equation with 2. So, I get 2Z2 plus 12 plus 16i is equal to 4. Now, I will take this 2Z2 as B, then it means B plus 12 plus 16i will be equal to 4. and we are interested in finding the range of mod of A minus B. So, what I have done here is by multiplying with different numbers and by assuming new variables, I have converted this question into the earlier question. So, that way we can proceed with this question. Okay. Now, I will move on to the next question. So, here argument of z minus I root 3 by z minus 1 belonging to pi by 2 to pi. Okay. So, here a interval is given for this argument. Now, first we whenever there is that kind of interval given, so first we need to work out a constant here. Instead of taking the interval here, take one constant. Okay. For example, let us say we are taking this argument of z minus I root 3 by z minus 1 is equal to, let us say there is a constant. Okay. So, I will take this constant as, let us say 2 pi by 3. Okay. Now, what will be the locus of this? So, to understand this, we need to understand the property of argument. So, argument of z1 by z2 is equal to argument of z1 minus argument of z2. Okay. So, this formula I have directly applied here, and then I can analyze what is going to happen there. But there is also a different way of understanding argument of ratio of two vectors. In complex numbers, every complex number is a vector. So, if I add two complex numbers or subtract, then also it means it is a vector. So, here z minus I root 3 means it is a vector, z minus 1 which is in the denominator is also a vector. So, if I take ratio of two vectors and apply argument on that, we will always get angle between the vectors. So, you can write it as a formula also, angle between vectors is always argument of vector 1 divided by vector 2. Okay. So, here basically we are understanding the angle between the vectors. Now, before that we need to analyze where are these vectors, what is the location of these vectors, what is the orientation. So, for that we need to plot basic diagram. So, let us say there is 1 here which is the real number. Now, z is one variable number, z minus 1 means vector starting from 1 and ending at z. Similarly, z minus I root 3 means vector starting from I root 3 and ending at z. Okay. And whenever we take the ratio of two vectors, you have to measure the angle going from the denominator to numerator. From denominator to numerator, always measure angle. So, that means denominator vector is this z minus 1 vector, numerator vector is this z minus I root 3 vector. Now, from here we have to measure the angle to z minus I root 3 vector, that too in anti-clockwise direction, that is the positive direction. Okay. So, here it is mentioned that this angle is always 2 pi by 3. Okay. So, if this angle is 2 pi by 3, then internal angle has to be pi by 3, which is the 60 degrees. So, basically here this z is moving such that this angle is always constant. Z is moving such that this angle is always constant. That means can you guess what is the locus of z? It is on a circle, because we have learned a property in school. Suppose let us say there is a chord here which is AB. Now, this chord makes equal angles on the circumference. That means, if I take any point here C, this angle, if I name it as theta, or if I take another point here D, and this angle also will be theta. Also, if you take any other point, the angle will still be theta. Okay. So, no matter where you are taking the point here, angle is always equal. But if you take on the other side, which is the minor arc, then also for all the points on this minor arc, angles will be equal, but that angle will be pi minus theta. You know the property of cyclic quadrilateral. So, if this angle is theta, this will be pi minus theta. Okay. So, here basically z will lie on circle, but it will lie on it will not lie on complete circle, it will lie only for a particular part of the circle, we can call it as arc. Okay. So, basically here we have observed that if this argument of the ratio is constant, we should be getting a circular arc. Okay. Now, what happens if this RHS is a constant which varies between pi by 2 and pi? For that we need to again draw the diagram and understand it. Okay. So, let me just erase all of this and try this again. So, now we are trying to understand for these two angles. So, suppose let us say there is one point here I root 3 and there is one point here 1. Now, I am not drawing the coordinate axis. Okay. So, there is a z here, let us say there is a z here, this is z minus I root 3 vector, this is z minus 1 vector. Now, if you are measuring angle like this, then this is going in clockwise direction. So, I will not take it this side, but if I take it this side, then angle is measured in anti-clockwise direction and it is matching to be 2 pi by 3 or any constant. So, whenever there is an involvement of sine, then you need to understand which location it is it above or is it below. For example, if you draw these 2 points, is it going to lie above this line or below this line? Depending on the sign and the convention that I explained, you can understand it. Okay. So, this is one part. Now, we are going to attack this question. Okay. So, let us say I root 3 point is here and 1 point is here. If this argument is equal to pi by 2, if that angle is fixed and if that is 90 degrees, then we get a semicircular arc. So, here we will get one semicircular arc. Now, if that angle is little bit increased, let us say 91 degrees, what do we get? We will get another arc which is minor arc. If the angle is acute, we will get major arc. If the angle is obtuse, we will get minor arc. So, here we will get another arc like this. Okay. And if I increase that to be 92 degrees, we will get another arc. So, like this, if I increase till 180, we will get all arcs till this diameter. So, when you plot all this region, you will basically get one semicircular portion. Okay. So, you can find the area of this using simple geometry that anyways you can do. So, here when we say plot the locus, this entire semicircular region is our locus. Okay. Now, suppose let us say if I vary the angles like this, pi by 2 to 2 pi by 3, let us say if I vary it like this, then we will get one crescent of moon, we will get one crescent of moon. So, it is just a slight variation. Okay. So, now to approach these type of questions, what is the procedure? First, apply the basic definition of whatever argument or modulus that is involved. Now, try to understand the location of the vectors and try to apply sign convention, and after that see if you vary that constant what happens. Okay. So, now whenever there is anything given, let us say mod z is belonging to 2 to 3. So, then how do you do it? You first fix mod z to be equal to k and then observe it, then vary that k between 2 and 3. So, that way you can clearly spot the locus. Okay. Can we move on to the next question? Here, if z1, z2, z3 form equilateral triangle, prove that this condition is valid. Okay. So, this question I am based on the complex rotation concept. Now, let us say here I will explain the concept. There is one vector here which is starting from z0 ending at z1. There is another vector starting from z0 and ending at z2. If the angle between these two is let us say theta, then we can always write it as z2 minus z0 by z1 minus z0. See here, if you notice, this is the ratio of two vectors. This is v2 by v1, which is the ratio of two vectors, is equal to one constant into e power I theta. What is this constant? This constant is the ratio of magnitudes of these two vectors. So, basically this becomes mod of v2 by mod of v1. It is the ratio of the magnitudes. And what is this theta? Theta is the angle of rotation between these two vectors. Okay. Now also here the rotation may actually not happen, but we are just trying to relate two vectors with this formula. You can visualize that there is one vector which is rotating and giving another vector, and the initial vector comes in the denominator, final vector comes in the numerator. This is one idea of interpreting it. Or the other idea is you need not visualize rotation, you can just understand that if there are any two vectors, ratio of those two vectors can be related with this formula. Okay. So, using this formula I will try to solve this question. So, here before we proceed, we have to convert these terms into the rotation form. How do we convert these into the rotation form? Let us say I take this first factor common, then I will get something like 1 plus z1 minus z2 by z2 minus z3 plus z1 minus z2 by z3 minus z1. We have to prove this. TPT, this means to prove that. To prove the above statement is same as to prove this statement. Now, how do we prove this? To convert this into the rotation form, we need to have one initial point and we need to have final point. So, and then initial vector and the final vector. So, we will do it like this. I will try to make sure that Z2 is getting one minus sign, because whatever is the point that is common to numerator and denominator must be the common point. So, I will do it like this. This is a slight variation in minus sign. So, this is one, and similarly I will do this for the numerator also. Okay, we need to prove this. So, now here if you observe this, you can understand that this is in the rotation form. Now, let us take a equilateral triangle. This point is, let us say Z1, this is Z2, this is Z3. Now, here it means there is a vector starting from Z2 and ending at Z1. I will use a different color here. Starting from Z2 ending at Z1, this is the vector. Here starting from Z2 and ending at Z3, this is the vector. Now, which is the initial vector, which is the final vector? Denominator is initial, numerator is final. So, denominator Z3 minus Z2, this is the initial vector and this is the final vector. So, rotation has to happen in this direction. Now, for this ratio, I can write it as constant k, which is the ratio of magnitudes, becomes 1 because these two sides are anyways equal. Okay. So, I can write this as 1 into e raised to, look at the rotation and the direction of the angle, it is in the anti-clockwise direction. So, it is a positive angle. So, I will just write it as pi by 3. You know that all angles in equilateral triangle are 60 degrees. So, I just wrote pi by 3 there. And similarly, for this term, I have to analyze in the similar manner. So, in similar manner, if we just apply it and if we write whatever we get here and simplify, we should get the 0. Okay. So, this way we can proceed for such kind of questions. So, whenever you want to apply the complex rotation idea, always you need to convert the given expression in the standard rotation form. Okay. So, this is the first example that I have given. It might be slightly confusing, but when I go to the next example, it will be very, very clear to you. As I used to say, first example sometimes may go bouncer, but second example kills the confusion. Okay. Now, let us say there is this question. This is a previous year question. Okay. So, Z1 plus Z2 omega plus Z3 omega square is 0. Then prove that these three form equilateral triangle, and here it shall be mentioned that omega is the cube root of unity. Okay. So, that must be mentioned in the question, that omega is the cube root of unity. If it is not mentioned, then you can take it as any number. Okay. So, here it was supposed to come, but it did not come. Okay. Now, how do we prove that they form equilateral triangle? So, here I will solve this question using complex rotation. Now, here what I am doing is, instead of omega square, I am writing minus 1 minus omega. Now, you know this idea, because for complex numbers 1 plus omega square is always 0. So, instead of omega square I wrote minus 1 minus omega. Now, I will take all terms with omega separately and without omega separately. So, I will get something like z1 minus z3 plus omega into z2 minus z3 is equal to 0. Now, this is one vector, this is another vector. Now, I need to convert this into standard rotation form. What I have to do is divide with one of these two factors and take omega to the other side. So, we will get something like this, z1 minus z3 by z2 minus z3 is equal to minus omega. Okay. Now, minus omega can be written as minus into the value of omega is minus 1 by 2 plus I root 3 by 2. If we simplify this, we get 1 by 2 minus I root 3 by 2, which is same as e power minus I pi by 3. So, we got a relation like this, z1 minus, I will just write it here only. So, it is e power minus I pi by 3. Now, this is the relation that we got. Now, try to compare this with the idea of z1 minus z3 by z2 minus z3 is equal to k into e power I theta. When we compare with this idea, what do we get? K is supposed to be 1 here, because here there is no other magnitude. So, that means there is 1 here. K is 1 means these two vectors, numerator and denominator, both vectors have equal magnitude, and also angle of rotation is 60 degrees. So, that means if you get one vector here and another vector here, if these two are equal and if this angle is 60 degrees, then whatever we join here with, that will also be equal, because if two sides are equal, then definitely it is isosceles triangle. Now, in the isosceles triangle, if the unequal angle is 60 degrees, it becomes the equilateral triangle. So, here we have just proved that it is equilateral triangle. Okay. Also, whenever you see this kind of condition anywhere, you can straight away proceed and conclude that it is going to be equilateral triangle only. Okay. So, if you look at the procedure, how did we do this? We converted the given condition into standard complex rotation form and then applied the idea of the rotation. Okay. Can we move on to the next question? So, here for an equilateral triangle, prove this condition where Zi are vertices and Z0 is centroid. Okay. So, here it is already given that there is an equilateral triangle and you wanted to prove that condition. So, how do we do this? This also I am using complex rotation and proving. Now, the reason why I have taken so many questions on complex rotation is because most of the students do not understand complex rotation well. Let us say this is Z0, this is Z1, this is Z2, this is Z3, and assume that this is going to be a equilateral triangle. Now, this vector which is the Z1 minus Z0 vector and this vector which is Z2 minus Z0 vector, if you check the angle between these two vectors, it is 120 degrees, which is also same as 2 pi by 3. Okay. So, if I apply complex rotation here, I will get something like Z2 minus Z1 by Z2 minus Z0 by Z1 minus Z0 is equal to, because these two are anyways equal, because it is equilateral triangle and this distance is going to be circumradius, it is equal. So, ratio of the magnitudes is 1 and e power I angle of rotation is 2 pi by 3. Now, you know that e power I 2 pi by 3 is the cube root of unity. So, that means I can just write it as omega here. Okay. Also, if I take this vector which is the Z3 minus Z0 vector and try to rotate Z1 minus Z0 and get this third vector. So, we can get a relation like Z3 minus Z0 by Z1 minus Z0 is equal to e power I 4 pi by 3. Here the angle is 240 degrees, which implies that it is omega square. I hope this is clear. Okay. So, now if we square these two and add, what do we get? Z2 minus Z0 square plus Z3 minus Z0 square divided by Z1 minus Z0 square is equal to omega square plus omega power 4, which is going to be omega square plus omega only, because omega cube is 1, omega power 4 can be broken into 2, omega cube into omega cube is 1, so it is omega. Now this becomes minus 1. Now if you take the denominator to RHS and simplify it, you will get something like this. Z2 minus Z0 square plus Z3 minus Z0 square equal to minus Z1 minus Z0 square. Okay. Now if you are watching this, try to take a snapshot of this, because I am going to remove this completely. Okay. So now what do we have to do is, we have to take the term in the RHS to LHS and we have to simplify it further. Okay. Now I will just erase this all and I will try to take only the last step and simplify this. So we got something like Z1 minus Z0 square, Z2 minus Z0 square, Z3 minus Z0 square is equal to 0. Now if I simplify this, I get Z1 square, Z2 square, Z3 square. I have taken all squares from the first term, and then there is Z0 square which is also coming. So Z0 square comes from 3 factors, so I will do into 3, and also from the remaining terms they look like this: minus 2 Z0 Z1, minus 2 Z0 Z2, minus 2 Z0 Z3, this is equal to 0. But here, because Z0 is centroid, we can say that 3 into Z0 is equal to Z1 plus Z2 plus Z3. Now using this relation, if we just substitute it, we will get the required answer. Okay. So this way we can proceed with this question. Okay. Can we move on to the next question? Here a relation between ABC is given, another relation between LMN are given, and if these ABC and LMN form 2 triangles respectively, then we have to choose the correct option. Okay. So here this question is actually confusing if you do not understand the complex rotation. So here I am going to solve this using complex rotation. Now here if you observe, in these two equations, the common complex number that is involved is the R. So here it is mentioned that all numbers involved are complex. Now the common number that is involved is the R. So what I will do is I will try to solve for R. Okay. So from first condition, if I solve for R from here, I get something like A equal to RB plus C minus RC. So R equal to, I get something like A minus C by B minus C. That is just simplification. And also from the second, if I solve for R, I will get R equal to L minus N divided by M minus N. Now here you can understand it using complex rotation like this. Suppose let us say there is a triangle which is the ABC, and here C is the common point, A, B here. B minus C is one vector, A minus C is one vector. We are rotating B minus C to get A minus C. So A minus C is the final vector, B minus C is the initial vector, and this represents a complex rotation. We can just assume like that. And similarly for another triangle, let us say there is another triangle, the common point is N that I am placing here, this is M, this is L. So this is M minus N vector, this is L minus N vector, and here also this is one complex rotation. But if you notice the ratio of A minus C, B minus C here, that means this side and this side is same as the ratio of this side and this side. So this equation that we got for R from both these two equations are equal. That means what does it indicate? It indicates that the ratio of two sides is same. Now if ratio of two sides is same, then that means the magnitude should be same and also argument should be same. So if magnitudes are same, then also we cannot conclude that it is congruent or similar. But when angle is same, we can conclude that these two angles are same and the ratio is same. So, hence they have to be similar. They can be congruent also as a special case, but they have to be similar here. So, in this particular question we can say that these two triangles are similar. Okay. So, now if you have any confusion, probably your confusion point would be this: when these two are equal to r can be generally written as k into e power I theta, which is the complex number. Now, k here represents the magnitude, theta here represents the argument. Now, if two complex numbers are equal, then that means magnitude must be equal and angle also must be equal, which is the argument. So, here that is what it means: ratio of these two sides and ratio of these two sides must be equal, and also the angle between these two sides must be equal. Now, if angle is equal, then there can be similarity. If the ratio is also equal, then there is similarity. Okay. It can be congruency also, but we can surely say that it is similar. Okay. Can we move on to the next question? Okay. So, here mod of I z power 4 plus 1 equal to mod of z power 4 plus 1, there is a condition given and we have to find the locus of z. So, how do we do this? Here if you notice, in the RHS there is z power 4 involved. Mod of z whole power 4 can also be written as mod of z power 4 whole mod, and there is 1 here. So, this term mod of z power 4 is here and 1 is here. So, what we will try to do is, we will try to get the z power 4 in the LHS also. Now, to get it, what I will do is, I will take this I common. So, if I take I common, I will get minus I in place of this 1, and there is I common. So, mod of I must come out. So, here what I have applied is mod of z1 into mod of z2. Okay. Mod of z1 z2 equal to mod of z1 into mod of z2. So, when I take I common, there is a separate mod and there is this separate. Okay. Mod of I is anyways 1. So, we can write this as mod of z power 4 minus I is equal to mod of z power 4 plus 1. This is the final condition on which I am going to apply the idea. Okay. Now, how do we understand this condition? Suppose let us say I take one Argand plane and here I take this point I. I is generally on imaginary axis, and if I take random point which is z power 4, okay, z power 4 is my point. Now, joining these two will give me a vector which is the z power 4 minus I vector. So, this is z power 4 minus I vector. Now, mod of z power 4 minus I will be the magnitude of this vector. Okay. So, this is one point. Now, that means I have interpreted this LHS term geometrically. Now, I am going to interpret this RHS term geometrically. Z power 4 means it is the vector starting from origin and going till z power 4. Also, mod means it is the length of this vector. So, here I interpreted these two which are starting from I and also starting from origin. Now, there is one extra term which is left, which is 1. Now, whenever there is that third term, we try to relate that third term with the given diagram only. In the given diagram, where could I fit this 1? If you observe, 1 is actually this mod of I. So, that means we can take this side as 1 unit. Okay. So, here if I take this point as let us say P, this point origin can be taken as O, and if this point is A. So, here it is given that PA is equal to PO plus AO. PA, which is this side must be equal to this side and also this side. Sum of these two sides must be equal to this second side. Okay. So, that means where could this location of P be? Where will this P point can lie so that this condition is satisfied. Okay. So, you can understand by simply varying P. If I take P here, then PA will be smaller than the PO. So, P cannot be here. So, if I take P here, then PA will be smaller than PO. So, it is not possible. If I take P here, then PA is definitely greater than PO, but it is not equal. So, like that hit and trial also you can apply, but generally you guys get very sharp ideas here. So, here P has to lie on this side. So, if P lies here, you can observe that PO is this length, 1 is this length and PA is the total length. So, here PO plus OA is equal to PA, which is perfectly satisfying the given condition. Okay. So, from this diagram we have understood that P has to lie on the negative imaginary axis. P has to lie on the negative imaginary axis. So, what is P here? P is the Z power 4. Now, we will try to calculate or find out where will Z lie. Okay. But till here we concluded where will Z power 4 lie. Okay. So, this is perfectly advanced level question because of the concepts involved here. So, one is we tried to take one I common and tried to interpret whatever is in LHS and RHS geometrically, and we tried to fit a perfect location for Z power 4. We got the location. Now, we will proceed with solving and finding out where Z could be. Okay. So, now for that I took a blank slide. Here I will write and explain. So, here we have understood that Z power 4 must lie on the negative imaginary axis. So, this is the negative imaginary axis. On negative imaginary axis, if you observe, what is generally the argument of negative imaginary axis? It is the minus pi by 2. That means, from positive real axis, if we observe the angle, it is always minus pi by 2. So, I can write Z power 4 as some constant which will represent the magnitude and e power I minus pi by 2, this represents the argument. But whenever we write argument while solving questions with higher order powers, we always write the general argument, which is 2n pi. Okay. So, here because magnitude is always non-negative, it does not matter what you take. I can take it as k or I can take it as k power 4 also. I took k power 4 just to make sure that there are no roots involved. If I take it as k, then also it is fine. Okay. So, now if I solve for z, I get something like z equal to k into e power I minus pi by 2 plus 2n pi whole divided by 4. What I have taken is I have taken the fourth root on both sides. Now, if I simplify this, if you also notice the way I am solving this is the way we solve for cube roots of unity and also nth roots of unity. Okay. So, in general when we solve for cube roots of unity, when we have equation like z cube equal to 1, we write this 1 with general argument, which is the e power I 2n pi, and then we take the cube root both sides. Okay. So, this is a better way of solving algebraic equations with higher powers, especially if z power n equal to constant is given. Okay. Now, here if I put n equal to 0, I get z equal to k into e power I minus pi by 8. Now, if I put n equal to 1, I will get z equal to k into e power I minus pi by 8 plus pi by 2. Now, this way I will get magnitude to be same here k, but angles are every time shifted by pi by 2 units. The next angle would be minus pi by 8 plus pi, and the next angle would be minus pi by 8 plus 3 pi by 2. So, here I got 4 solutions for z depending on n going from 0 to 3. Now, later on if I put n equal to 4, n equal to 5, same solutions will repeat. Now, if I plot all these solutions, where would all of them lie? I will take a different color here. Now, here magnitude k can vary, it can be 1, it can be 2, it can be 3 or anything, but angle is fixed, which is minus pi by 8. So, That means we will get one ray here, this is one ray whose argument is always minus pi by 8. So, here if you observe only argument is constant, but magnitude is not constant. Here when we took z power 4 equal to something, here what we fixed is we fixed only argument, not the magnitude. Why? Because on this negative imaginary axis z power 4 can be anywhere. So, magnitude is not fixed, only the angle is fixed. So, hence here also magnitude is not fixed, only the angle is fixed. So, I got a ray here because it has to cover all points which make the angle minus pi by 8. Now, if we go for the next one, which is minus pi by 8 plus pi by 2, that means this has to shift by pi by 2, 90 degrees. So, we will get another ray here. Now, for the third case, we will get one ray here. For fourth case, we will get one ray here. So, this will mean that there are 4 rays here. Now, if you are lucky, these 4 rays will form 2 straight lines, and here you are, because these will make 2 lines here. So, we can say that the locus is going to be one pair of straight lines. Okay. So, here when we go to geometry of complex numbers, explanation takes lot of time, but working is not that slow, working is super fast, because if geometric ideas are clear to you, you can solve them very, very fast. Okay. So, here what is the conclusion? Conclusion is the locus is pair of straight lines. Okay. Now, if you look at the entire process, we started with simple condition of understanding this on the geometry, and then we arrived at a location for z power 4, then we used algebra, and then we arrived at some solutions for z, then plotted z. This is the geometric way. Conceptually, this has 2 different concepts. Now, but you can also solve this question by taking z equal to x plus iy and simplifying it algebraically, pure algebra, but that is going to involve 4th degree equations, which is a headache. Okay. So, try not to get into substituting z equal to x plus iy, and 90% of the time try to solve them using only pure geometry, so that you will be able to solve questions. Okay. Now, I will go to the next question. This question is based on a triangular inequality. So, in general, when we have, let us say, a z1 plus z2, so the mod of this is always less than or equal to mod z1 plus mod z2. This is the simple form of triangular inequality. If we extend this to n terms, we can write it as mod of z1 plus z2 plus z3 is less than or equal to mod z1, mod z2, mod z3. These are individual. Now, not just 3 terms, you can also extend this for n terms. Okay. So, this question is based on extending this for n terms. Okay. So, that means I can write it like this: 4, which is equal to sin theta naught plus z into sin theta 1 plus z square into sin theta 2 and so on till z power 6 into sin theta 6. This is the given equation. Now, we have to prove that roots do not lie inside this circle. Mod z equal to constant means it is a circle. So, what I will try to do is I will try to apply triangular inequality on this. So, first I will apply mod here. So, if I apply mod on both sides, of course, they have to be equal, but further this RHS can be written with triangular inequality like this: mod of sin theta naught plus mod of z into mod of sin theta 1 plus mod of z square into mod of sin theta 2 till last term mod of z power 6 into mod of sin theta 6. I can write it like this. So, here what I did is I applied modulus individually for each term. Now, also in each term, when there is a product, I try to separate the product using mod of z1 z2 equal to mod z1 into mod z2. Now, further there is this identity that sin theta cannot be greater than 1. So, mod of sin theta can be put as always less than or equal to 1. So, that means here we can say that this is further less than equal to 1 plus mod z square till mod of z power 6. Is this clear? So, what I have done here is I applied triangular inequality, then I applied the identity for sine, which is that range of sin theta will not go beyond 1. Okay. So, now because there is 4 here in LHS, I will just write 4 here. Now, I want to analyze this condition and I want to prove that roots do not lie inside this. So, that means for this condition, if I prove that mod z is always greater than 3 by 4, then that means I have proved the required condition. Now, how do I proceed with this? So, here if I observe, I am getting two ideas in my mind. One is what happens if mod z is greater than or equal to 1. If mod z is greater than or equal to 1, RHS is definitely greater than LHS. So, this condition is naturally satisfied. So, this will not create any problem. So, here we can just say that condition is satisfied. Now, our focus is, if you remember, we are targeting the mod z equal to 3 by 4. So, that case will come when I take the second possibility where mod z is less than 1. If mod z is less than 1, then what happens? Then RHS can be simplified like this. 4 is less than equal to 1 minus mod z power 7 by 1 minus mod z. Now, what have I applied here? I applied the formula of GP. Okay. So, here this looks like 1 plus r square till r power 6. So, 1 minus r power 7 by 1 minus r. Now, because mod z is less than 1, I can say that this is further less than 1 by 1 minus mod z, because mod z is a small number which is between 0 and 1. Mod z power 7 will also be a small number. Now, if I check these two numbers 1 minus z power 7 and 1, which will be bigger? 1 is bigger. So, I can say that this 1 by 1 minus mod z is definitely greater than this. Okay. So, if I proceed with solving for mod z, I will get the required condition. Okay. So, here I just have to solve for mod z. Now, let me see if there is vacant space. So, here we got something like 4 less than equal to 1 minus mod z power 7 by 1 minus mod z, which is less than 1 by 1 minus mod z. Now, I will just simplify it, because mod z is between 0 and 1, 1 minus mod z is also a positive number. So, if all positive numbers are involved around an inequality, you can cross multiply and just play with it. So, here 1 minus mod z less than 1 by 4. So, 1 minus 1 by 4 less than mod z. This means mod z is greater than 3 by 4. So, here we got the relation that even in the case when mod z is less than 1, even in that case mod z cannot be less than 3 by 4, mod z has to be greater than 3 by 4. So, this means we have proved that mod z equal to 3 by 4, that circle, and inside that circle we cannot get any roots for this equation. Okay. So, here this question is previous IIT question. So, I took this to demonstrate the 2-3 ideas, which are: first, triangular inequality for n terms; second, identity of sin theta is involved. So, two concepts are involved, and then this making of cases is also involved. So, here 3 techniques are involved in this question. So, as I used to say, in IIT Advanced you generally get multiple concepts. Okay. So, can we move on to the next question? So, here if A1, A2, A3, An is a regular polygon of n sides with circumradius r, find the product of lengths of all diagonals passing through A1. So, let us say that there is one polygon here, okay, and this vertex is A1, this is A2, this is A3, this is A4. So, like this we have a polygon. Okay. So, now through A1 we want to find product of all diagonals. Okay. And there is this data given which is circumradius is r units. Okay. So, that means from center all these points are at the distance r units. So, that means this is a regular polygon. Okay. Now, we want to find product of lengths of all diagonals through A1. Now, how many diagonals will pass through A1? So, if you take A1 and A2, there will not be any diagonal passing through these 2 points, and also there will be another point here which is adjacent to A1, which is the AN. So, now A1 AN cannot form a diagonal. So, except these 3 points, all diagonals that pass through A1 will also pass through the other points except these 3. That means how many are remaining? N minus 3 are remaining. So, there are N minus 3 diagonals passing through A1. We want to find length of all these diagonals. Okay. So, how do we do it? To solve this question, we will try to use the concept of roots of unity. So, if you take nth roots of unity, they also form a regular polygon around unit circle. Okay. So, now, that means around unit circle we have to form, we generally form a regular polygon for nth roots of unity. See, it's I already crossed 1 hour. So, now there is a reminder that I have crossed 1 hour. So, I will just extend for 5-10 minutes and finish these concepts. Okay. So, here I am going to use concept of nth roots of unity. In general, in nth roots of unity there is regular polygon. Now, here also there is regular polygon. So, what I will do is I will try to fit that concept of nth roots of unity into this regular polygon. Now, imagine that there is this regular polygon of the nth roots of unity only, where circumradius is only 1 unit, that is for the nth roots of unity. Now, if I expand it and make sure that the circumradius is r units, so here I can take this as origin, I can take this as the real axis. This is my first root which is the 1, in general 1, but here okay, I will first write for the nth roots of unity. Okay. So, let me just erase this and draw the diagram again. Let us say this is my origin, this is my first point. So, generally when I plot nth roots of unity, this is 1 and there is one alpha here, there is one alpha here, there is one alpha square here and there is one alpha cube here. Like this every point will come on the unit circle. But now if I take the circumradius to be r, I can take these points as r, r into alpha square, r into alpha cube and so on. Now, that means the nth vertex can also be written as r into alpha power n minus 1. Okay. So, basically this point is A1, this point is A2, this point is A3, this point is A4 and so on. Now, if I take the length of the diagonal, A1, A3, so now that means it is the distance between 2 points. So, in complex numbers distance between 2 points is mod of z1 minus z2. So, that means here we can just say that r minus r alpha is going to be mod of z1 minus z2, which is the A1, A3. Similarly, if I do A1, A4, wait a minute, this is alpha square must be there because this is the A3, A3 is r alpha square. Now, similarly, if I do A1, A4, it will be mod of r minus r alpha cube, that is the A1, A4, you can understand this. Now, further if I continue till A1, An minus 2 or An minus 1, okay, A1, An minus 1, that is last but one vertex. So, it will be r minus r into alpha power n minus 2. Okay. So, this way we can generate the lengths. Because we want product of all these lengths, we will just have to multiply them. Okay, so I took a blank slide here. So product of all of them will be like r minus r alpha mod into r minus r alpha, it has to be square, so it has to be cube, into r minus r alpha power 4 and so on till r minus r alpha power n minus 2. Now, if we take r common, how many terms are there? Because there are n minus 3 diagonals, there will be n minus 3 terms here. For every term, I am taking r common, so r power n minus 3 into mod of 1 minus alpha square, 1 minus alpha cube and so on till 1 minus alpha power n minus 2. Okay, this is what we got. Now, further, if you want to find this sum, we can use the concept of roots of unity, where z power n minus 1 can be factorized into z minus 1, z minus alpha square and so on till z minus alpha power n minus 1. Now, here if I put, let us say, if I take this z minus 1 to the LHS, I get something like z power n minus 1 by z minus 1, which can also be written as 1 plus z square till z power n minus 1. Now, in place of z, if I put 1 here, if I put 1 here, I will get something like 1 minus alpha square till 1 minus alpha power n minus 2 into 1 minus alpha power n minus 1. This is equal to n. This is the general identity that we derive from the roots of unity. So, now if you compare this term with that term, there are only two terms which are extra. This is the n minus 1. Okay. There are only two terms which are extra. If we supply them, we can directly put n there. So, here we can write it as r power n minus 3 into n by mod of 1 minus alpha into mod of 1 minus alpha power n minus 1. Now, these two you can simplify and write. Okay. For example, mod of 1 minus alpha can be simplified using a simple formula of alpha, which is alpha is equal to e power I 2 pi by n. You know this formula for nth root of unity. You can further simplify it, and when you convert this mod of 1 minus alpha, you will get 2 sin theta by 2 or something, that you can simplify and further proceed. Okay. So, here this can be typically one advanced level question where a polygon is linked with the roots of unity. Okay. So, first idea is to link directly vertices of the polygon with roots of unity, then convert the question into roots of unity and play there. Okay. So, this way we can proceed with this question. Okay. So, I am not completing the solution here, I will leave that to you, but you will get only 2 sin theta by 2 here, here also you will get another 2 sin theta by 2. Okay. So, that I am leaving to you. What is theta, that you will just work out. Okay. Can we go on to the next question? Now, here we have to find the locus on which the roots lie. Whenever we want to find the locus on which roots lie, what do we have to do is we take the all the knowledge that is involving in locus from complex numbers chapter. So, if you check all equations which give locus, they either have a modulus condition or they have argument condition. So, what I will try to do here is I will try to apply modulus or the argument on this directly. So, most useful form is the modulus form. Suppose let us say if I put modulus here, I will get something like this. Now, mod of z power n is same as mod z whole power n. So, I can just write it as mod z whole power n and here mod z power n whole power n. Now, this means because for mod z there is no way of getting complex numbers, because mod z is a positive or non-negative real number. So, we can just cancel out n and write it like this. Okay. Now, if you look at this statement, mod z means distance of z from origin. Let us say there is z here. So, distance of z from origin is mod z. Mod z minus 1 means distance of z from 1. Now, if these two distances are equal, That means z has to lie on the perpendicular bisector of 0 and 1. Now, what is the perpendicular bisector of 0 and 1? That is a vertical line where x is equal to 1 by 2. That means here whatever are the roots that we will get will lie on this line only. Okay. So, here what is the locus on which roots lie? It is a straight line. Okay. Now, further if we want to find sum of all roots, we have to check how many roots are possible. So, here if you observe the equation, the highest power in LHS is z power n, highest power in RHS is also z power n. Z power n may get cancelled here, that means the number of roots that we will get will be only n minus 1 roots. So, one is we first step is we concluded what is the locus, second step is we check if there are any roots which are not available now. In general, if there is nth degree, n roots are available, but if the highest power is cancelled, that means you just missed one root. Okay. So, that means here n minus 1 roots are there and every root will have real part to be 1 by 2. Now, here if you observe, let us say if there are let us say 9 roots above x axis, above real axis, there will be 9 roots below real axis also, because the equation is a real equation. So, if complex roots come, they have to come as conjugate pairs. So, if there is one root above real axis, there should be another root above below real axis. Now, when you add all of them, imaginary parts get cancelled and only the real parts will remain. Is this clear? If there is any root on the real axis which is the z equal to 1 by 2, if it is possible, then there could be, but otherwise whatever is above, you should get another root further which is below real axis. Now, for n minus 1 roots, we can just say that sum of all roots is n minus 1 by 2. This by pure geometry we can say, or by opening this, by expanding this using binomial theorem also, we can conclude that sum of roots will be this. Okay. Now, we will move on to the next question. Okay. So, there is one more question here. So, here it says 1 plus alpha power k whole power n has to be expanded and k has to be varied from 0 to n minus 1. Okay. Now, here if I let us say expand this 1 plus alpha power k whole power n, what do you get? Nc naught minus Nc1 into alpha power k plus Nc2 into alpha power 2k minus Nc3 into alpha power 3k and so on. Okay. Now, here I have not applied the sigma on this. If I apply sigma, it is going from 0 to n minus 1. So, that means for n terms we are adding this. Okay. So, if I add Nc naught n times, what do I get? Sigma of 1 plus alpha power k whole power n. So, here I am adding Nc naught for n times, I get n into Nc naught minus Nc1 into, here I am applying sigma for n terms. So, here little bit rough work is required. So, when I put k equal to 0 and k equal to 1, k equal to 2, till the maximum value of k is how much? N minus 1. Now, here if you simplify this a bit more, you get 1 plus alpha square till alpha power n minus 1, which is sum of all nth roots of unity, which is 0. So, that means when I apply sigma over this, I will get Nc1 into 0. Similarly, when I apply sigma over this, I will get Nc2 into 0. Okay. For example, here there are n roots. If you square all these roots and add all of them, you will get 0 again. Okay. That means, if I let us say write this statement 1 plus alpha power k, alpha power 2k, alpha power 3k and so on till the last term. If k is not a multiple of n, then sum is always 0. If k is not a multiple of n, sum is always 0. So, we can conclude that all these terms which are going to be there till n minus 1, all of them are going to be 0, because k is not going beyond n minus 1. If k is multiple of n, then all of them may give 1s, but k is not a multiple of n. So, all of them will give 0, including the last term. Okay. So, here we can just simplify it like this. So, let me just explain for the last term also. So, NC3 into 0 and so on. Now, for the last term, I will get something like alpha power kn NCN. Now, but alpha power kn is 1, and also we are applying summation for n terms. So, there will be one extra term here. Okay. I will just explain it with this rough work. Alpha power kn can be written as alpha power n whole power k. Alpha power n is anyways 1. So, this is 1 power k, which is 1. So, that means the last term is NCN into this term. So, NCN into 1. Now, when we apply sigma over this, we will get NCN into n. NCN is anyways 1, so we can just write it as 1 into n. So, here basically these two terms come like this. So, we got first term which is n into 1, and we got last term which is 1 into n, which is 2n. All other terms are 0 here. So, what I tried to do here in this question is I mixed binomial theorem with the roots of unity and one special property of roots of unity. What happens if we take power k on all roots and take the summation? If k is multiple of n, you will get all terms to be 1, that means sum will be equal to n. If k is not a multiple of n, then summation of all terms will be 0. Okay. So, if you observe all the questions of today's lecture, I tried to mix as many concepts as possible, and also I tried to cover as many concepts as possible. Okay. So, if you take these ideas and if you develop your own algorithms for problem solving, and if you practice more questions, then I am sure your complex numbers chapter will be very strong. Mostly this chapter is the chapter which students skip for the exam, but do not skip. Try to at least practice the ideas that I have discussed in this lecture. Okay. So, I hope you enjoyed the lecture. We will meet after a short while for Q&A. Hello students, welcome back to doubt session. So, again before we go into doubts, please make a plan for every question and solve it. Okay. If you are able to make a plan till the answer, then proceed, otherwise do not proceed. Okay. So, question came here. Okay, so how many roots of this, and also there is another one. I guess these are two questions. This should be one question. Okay. This should be one question, this should be other question. Now, it is not mentioned which is the one that student wants. So, I will explain both. Okay. So, for the first question if we take, it is z power 4 plus I z bar is equal to 0, and here the logic is only to find how many roots are there. If it is how many roots, then it is much easier than finding actually the roots. Now, how do we do this? First step before finding the roots is to find the locus on which the roots lie. So, here for this what we can do is we can take one of the terms to the other side and we can apply mod on this. Okay. So, now what do we get? LHS becomes mod of z power 4 and RHS can be written as mod of minus I into mod of z bar. Mod of minus I is 1 and mod of z bar is mod z only. Okay. So, mod z power 4 equal to mod z. There are two cases arise from this situation. One case is mod z is 0, other case is mod z is 1. Okay. So, if mod z is 0, we have to solve for z again. If mod z is 1, then also we have to solve. But for mod z is 0, then it obviously means that z is equal to 0. We got one solution here. If mod z is 1, then how do we proceed? For that we have to take that case and solve it separately. So, here if mod z is 1, we can always write z bar as 1 by z. So, the equation becomes z power 4 plus I into 1 by z is equal to 0. this implies it is z power 5 plus I is equal to 0. So, if you observe, this is fifth degree equation, it will have 5 roots. There is one root here that we confirmed. So, total there are 6 roots to this question. Okay. So, this is easy question, so that is why I also solved this. But if you are interested in finding the values of the roots, you have to take this I to the RHS, z power 5 equal to minus I. You have to write this minus I in polar form, that is e power I minus pi by 2, but with general argument. And then now in the power take 1 by 5, take the fifth root, vary n from 0 to 4, you will get 5 roots. Okay. This way you can proceed with solving. Okay. Now I will solve the second one. Okay. So, if you are writing notes and if you are not able to write notes, just go back by 10 seconds and take a snapshot. Okay. So, next I am taking z1 and z2 be two distinct complex numbers. Okay, can we zoom it? No, we can't zoom it. Okay. T is something, so I will just write it for you. If it is not visible to you, I will write it in my big letters. Okay. Condition like this is given, and if argument of W denotes the principal argument of non-zero, okay, that is the definition, that is fine. Okay. So, we have to solve the 4 options. Now, here it is given that T is a real number which is between 0 and 1. The condition like T less than 1 itself tells that T is a real number, because if it is a complex number we cannot compare it with real numbers. Okay. In complex numbers there is nothing like z1 less than z2 or z1 greater than z2. You can compare moduli of complex numbers but not complex numbers, because they do not have any value, they are the imaginary. Okay. Okay. So, T is a real number and it is satisfying this. So, if you observe these two values, okay, sum of these two values is always 1. So, any time if you get this relation z equal to alpha z1 plus beta z2, where alpha plus beta is equal to 1, if you see this relation anywhere, it means it is a section formula. Okay. So, that means z is going to be a point lying on the line joining z1 and z2. Okay. Now, if the ratio of alpha and beta is positive, then that means it will be on the line segment only, but if ratio can be negative, then it can lie on anywhere on the line. Okay. So, here it is very clear that z1, z2 and z are going to be collinear points. Okay. So, let me just remove this part. So, here if let us say z1 is here, z2 is here, z has to lie somewhere on this line segment. So, we just concluded it. Now, try to see which options are valid. Okay. First option is z minus z1 modulus, that means this distance, z minus z2 modulus, that means this distance. So, if we add these two distance, we should get z1 minus z2 modulus. So, that is possible here. So, if I take this as P, take this as A, take this as B. So, first option is basically PA plus PB equal to AB, which is satisfied. So, first option is right. Second option, if we check, let me again erase this and draw it again. Second option, if we check, Z is here, Z1 is here, Z2 is here, Z minus Z1 vector is this, Z minus Z2 vector is this. Are they having same argument? Of course not, because direction is different. If one has argument theta, other will have pi minus theta or pi plus theta. So, because they are in opposite direction, we cannot say that they are equal. So, second is wrong. Now, third, if we say, third is mod of z minus z1, okay, z bar minus z1. This is the basically the equation of line. Okay. So, if we just simplify this, we will get something like this. Okay, by the way, let me just solve the D option first and then I will solve the C option. Z minus Z1 is this vector, Z2 minus Z1 is this vector. Now these two are having the same argument because both are going in same direction. So D option is also right. Okay. So now let me solve the C option. So till now we have concluded that A is right, B is wrong, D is right. Now I will check C. Okay. So if I simplify that determinant, I will get Z minus Z1 into Z2 bar minus Z1 bar is equal to, okay, it is not given here. So there is no other condition given, this is equal to 0 or something must be there. So just a determinant will not suffice. So there is no point in solving this, but if we take, let us say, assume that there is a mistake in the question, of course, but let us say this is given as 0, then what to do? So this is what we will do. This is like determinant AD minus BC. So Z2 minus Z1 into Z bar minus Z1 bar. Okay. Now I will try to take Z minus Z1 terms in LHS and Z2 minus Z1 terms in the RHS. Okay. So this means this is Z, this is Z1. So Z minus Z1 divided by Z bar minus Z1 bar, this becomes the 2 into real part of this vector, 2 into real part of this vector divided by 2 into imaginary part of this vector. So it looks like x minus x1 by y minus y1, it sounds like this. And similarly, if I do the RHS, that also looks like y2 x2 minus x1, x2 minus x1 by y2 minus y1. So these two conditions, LHS and RHS, these two terms are sounding like this. So that means it is basically the equation of line, okay, or let us say slopes are equal, okay, direction is same. So third is also right, okay. So here A, C and D are the right options, okay. So I tried to take as many doubts as possible, but I could take only 2 doubts. If you have observed the entire lecture, so most of the time I have used mainly the geometry. I used more geometry and less algebra. Of course, in some questions algebra is going too long, but that is fine because those are meant to be long questions, okay. But if you look at the majority of the questions are solved using geometry only. For example, if you even check that 8th question, this is like 2010, probably this is IIT question, IIT advanced question and multiple answer question, of course then it will be advanced only. So even in this question we are using the geometry. If the geometry is clear, if you know what is modulus, what is argument and how to connect them, then your working will be very fast, okay. So try to develop your own algorithms for different types of questions. For example, in this chapter, if question involves modulus, this is how I will think. If it involves an argument, this is how I will think. If it involves roots of unity, this is how I will think. If an equation is given and I want to solve for the roots or I want to find the locus on which roots lie, probably I will apply modulus or argument. So like this, if you try to list down, let us say some 10 to 20 questions, tough questions of this chapter, whichever you find, and if you observe the methods of them and if you list it somewhere else, then you do not have to recall them, revise them also. If you write once, then that is equivalent to reading 10 times, as elders used to say. If you write once, it is equivalent to reading 10 times. So even if you make a notes and just forget it, you will remember it in the exam whenever that situation arises. Because once if you solve a question, your mind has processed that complete program. That program you will remember when you attempt any question of similar kind, okay. So try to make a list like that and try to design your own methods for problem solving, okay. So I hope you enjoyed the lecture. We will meet again after a few days with a different concept and different chapter. Until then, have a great learning day. Learning shall never stop.